You are watching the 3.7 lesson video on applications of linear functions day 2. On applications of linear functions day 1 notes, we did not focus a lot of time on the graphing piece and making that connection, so that is exactly what we're going to do in this lesson. One thing that I will say is that when we were dealing with these types of problems, we're usually given paragraphs. So it's very important to organize your thoughts. Using different colors is something that I find to be really helpful. We're going to underline, highlight, kind of just make connections. Because if you can't organize what they tell you in the words and put it into math in a simpler way, these problems will be very difficult. And I'm constantly looking for clues and things to tell me, almost like little cheats along the way. Like, did they tell me the variable? If they did, that means I can label my x and y axis very easily. So let's read number 1. It says, Tasty Treats Bakery sells apple and pumpkin pies for Thanksgiving. It costs a bakery $3 to make an apple pie and $2 to make a pumpkin pie. Okay, so already I know I'm dealing with two things, apple pies and pumpkin pies. We know the bakery has $60 to spend on supplies. It says here to write an inequality that can be used to determine the amount of apple pies x. Oh, awesome. Okay, apple pies is my x variable, and this is the amount of apple pies, and the amount of pumpkin pies is y. The bakery can make with a maximum of $60. Okay, let's break it down. A maximum of $60. That means that they can spend $60, but they can't spend any more than $60, which means less than. Oh, you know what? Let me make that black, because I'm going to use my green anytime I'm talking about apple pies. So less than or equal to 60 is something that we are going to need in our problem here. Okay, I'm just going to bring that down, maybe revisit it in a minute, because I'm looking at my y and x axis, and I can see that they're not labeled, but looky here. They told us what x is. This is the amount, or the number, of apple pies. And my y, which is in blue, is the number of, not apple pies, but pumpkin pies. So what I'm going to do next is read in my problem. Did they talk to me anywhere about apple pies and pumpkin pies or quantities? Well, let's see. It says it costs the bakery $3 to make an apple pie. So $3 to make an apple pie. And $2 to make a pumpkin pie. So these are all connected. Notice how I'm using green for apple, blue for pumpkin. Let's put 2 and 2 together. Well, not really 2 and 2, but let's put it together. $3 for an apple pie would be 3x, and $2 for a pumpkin pie would not be 2x, but rather 2y. If we add the total cost of the apple pies and the total cost of the pumpkin pies, it can't be any more than 60. So let's actually do that. So we are going to add the cost of the pumpkin pies with the cost of the apple pies, and that can't be any more than 60. Dun, dun, dun. We have our inequality. So let's graph it. Well, some of you might say, that's kind of hard to graph, Mrs. Ruscio. I don't know what to do here. So we have a couple options. We can find our x and y intercepts algebraically by putting in 0 for either the x or the y, or we can get it in slope-intercept form. I think a lot of us are really comfortable with slope-intercept form, so let's go ahead and do that. All right, I want to keep my y where it is, but I don't like the fact that my x is over on that side. So let's sort, let's bring it over, and I'm just going to switch all my colors to black now. So 2y stays is less than negative 3x, and then the 60 is where I want it to be. Next, we're almost there. Let's get y alone by dividing every single term by 2. So my final inequality is y is less than or equal to negative 3 halves x plus 30. Now each one of my grid marks is worth 2. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And here's my y-intercept. So let's plot that right on the graph. All right, let's do my slope. So down 3, oh, wait a minute. Each one of these is actually worth 2. So down 3 would actually be down there. Ew, I don't want to deal with not nice grid marks. Let's think about this in a better way. Here's my slope. -3 over 2. How can I rewrite that? It looks like I want even numbers, don't I? Yeah, because 2 and 2, so each one of those grid marks is 2, so let's just multiply both numbers by 2. So -3 times 2 would give me -6. -2 times 2 would give me 4. Oh, so this might be a little bit better to generate the rest of the points. Let's try it. So down 2, 4, 6, to the right 4. So 2, 4, 6, to the right 4. It's not over here, remember, because of our scale. So down 2, 4, 2, 4, 6, to the right 4. 2, 4, 6, to the right 4. And we'll just keep following this pattern until we get to our x-axis. Notice how I'm not going to graph this anywhere in the negative range because I don't care about negative money and I don't care about, actually no, I don't care about negative pumpkin pies or negative apple pies. That doesn't make sense. All right, solid or dashed line. Well, we're dealing with a less than or equal to symbol, which is what we have right here. So that means I am going to have a solid line because it can equal all the points on that line, but I'm dealing with all of the values that are smaller than or lower, which means I shade below my inequality or below my line. So all of the points in here I would consider to be part of the solution. We could even put an S in there. And there you have it. We've graphed our inequality. And it looks like we have a guiding question. It says, give one example of the number of each type of pie the bakery could make. I have endless well, I don't have endless possibilities because I don't want halves of pies, but I could pick any single point in the shaded area or on the line because it's a solid line, and it would hold true. So what would this mean? Let's just pick a random point. Let's use this one right here. So this is 2, 4, 6, 8. 2, 4, 6, 8. Okay. Well, you know what? I'm going to pick a better point. So that's one of them. Let's pick another one. Let's pick this guy here. So my numbers are different. So this is 2, 4, 6. And then 2, 4, 6, 8, 10, 12, 14, 16. 6 is my x. 16 is my y. So that would mean I can't just leave this as my answer. This would mean 6 apple pies, because remember that's my x, and my pumpkin pie is my y, which would be 16 pumpkin. And a lot of times I actually just like to check my work. I will multiply 6 times, well, we said that the apples were worth what, $3 each? Yep, so 6 times 3, and then my 16 pumpkins, 16 pumpkin pies, I should say, be 16 times 2. So 16 times 3 is 18. 16 times 2 is 32. And I need to make sure that I didn't spend any more than how much money? $60. Or Tasty Treats Bakery didn't spend. So that Tasty Treats Bakery didn't spend any more than that. So 18 plus 32, that looks like it's exactly 50. So that's a combination of pies. Moving on to question number 2, let's just read it. It says a local soccer stadium charges $16 per each adult ticket and $8 per each student ticket. Okay, it looks like I'm dealing with adult and student tickets. On Friday, the total number of sales was $1,600. It says here to write an equation that can be used to determine the number of adult tickets X. Oh, awesome. They tell us that the adult tickets are X and the student tickets are Y. Let's just label our axes. So the number of adult tickets, which it says right in the problem, and the Y is the number of student tickets. And it's saying that we're sold on Friday. Since I'm dealing with a total, it seems to me that I'm going to be adding things and realizing that they add to 1,600. So something is going to have to equal $1,600. Let's talk about it. So up top here, it looks like I have $16 per adult ticket and $8 per student ticket. So immediately I'm doing my color coding again, as you can see. So 16 per adult and $8 per student. If I add both of those two together, I should equal $1,600. All right, so last problem, I showed you how to graph putting it in y equals x plus b form. And maybe what we should do in this problem here is use our x and y intercepts to help us and maybe connect those two together. So this is just another way to graph a line. And to me, it really doesn't matter how you do it as long as you have at least 3 points on the line. So we might have to add one in there in the mix. We'll see what happens when we graph. All right, let's put in 0 for our x value. Because if we do that, we'll get a y value on the y-axis, which we all know is the same as the y-intercept. So 16 times 0 is nada. We're just left with 8y is equal to 1,600. And divide both sides by 8. We end up getting y is equal to 200, which tells us that our y-intercept is a point 0, 200. So 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. Here's my y-intercept right here. Let's find our x-intercept. So copy paste, but instead of putting in 0 for my x, I will put in 0 for my y value. 8 times 0 is just 0, so we're just left with 16x is equal to 1,600. Again, we're going to divide both sides by 16, and we end up with x equaling 100. All right, so that's my x-intercept of 100, 0. So 20, 40, 60, 80, 100. Right now we only have 2 points, but let's connect them together to show that we have this decreasing line here. And immediately I see some nice intersecting points. There's one. Where's another one? Here's another one. There's another one. And there's another one. We can see that pattern. We're going down 40 as we move to the right 20. And it's 40 because we're going down 20 per grid mark. And do we have to worry about shading? The answer is no. Another way that you can verify to make sure what you're doing is correct is by using our technology. So right away, I notice that my line is not in the y equals mx plus b form, so we're going to change this to relation, but now we can just type in 16x plus 8y, and that equals 1,600. And then hit enter, and nothing appears, and you might think, what did I do wrong? Well, we didn't do anything wrong. Look at how large our scale is. This is 260, 280. I mean, we don't care about the negative, so let's change this to 260. Oh, there it is. And let's change that one to 280. There it is. So now you can see that our line is working out well. We have it in the right spot, it looks like. We could go into the menu and look at the Analyze Graph feature to get the 0, the x-intercept if we want. And we can see that 100, 0 is on there. We could use the trace feature to get the y-intercept. So make sure to use your technology to verify that what you're doing is correct. Now it says give one possible combination of student tickets sold and adult tickets sold. Well, now that we have all these points on our graph, we can pick any one of those. How many points did we plot? 1, 2, 3, 4, 5, 6. 6 points. And don't be fooled, there are actually way more points than that, but those ones are the easiest to find. So let's maybe use this one right here. So that is the point 20, 40, 60, 80, 20, 40. So interpret this. Our X are the adult tickets and Y are the student. So 80 adult tickets and 40 student.